All right, welcome to our very first lesson in geometry. This playlist is going to be trying to document the entire year of pre-AP lessons. I am Mr. Love, also known as the Math Patriot, and let's keep on going. Props to anybody who's actually watching this who's not a member of my class. Okay, so we're starting off with points, lines, and planes, the very basics of geometry. Now, I used to believe my students when they told me that they had never seen this stuff before. But then, now that I've got teenagers in high school, I helped them through all of their middle school assignments, and I saw the fact that they were actually covering a lot of this stuff in the middle school. So very few of this, or very little of this stuff should be familiar to you. I'm sorry. Very little of it should be new to you. Most of this is going to be familiar, okay? Here's the thing I need you to focus on today. Notation, notation, notation. Yeah, you've got to learn how to use proper geometric notation when you're naming points, lines, planes, and everything else will cover the rest of the year. Okay? Also, be careful with the way that you're saying things as well. We're going to start talking about lines and like line AB. Line AB is very different than segment AB, which is different than ray AB, which is different than circle A, which is different than arc AB, and different than just AB with no prefix on it. Okay? You're going to have to learn the difference between all of those. And we also want to make sure that we are using the proper words so we all know we're talking about the same thing. Because if I'm referencing line AB and you're referencing segment AB, that can start being confusing sometimes. So we're going to be working about accuracy of language. Okay? So points, lines, and planes are very beginning building blocks. Okay? You guys have seen all of this stuff before. All right? You know that a point is a dot, a line looks like that thing you were drawing all the time in Algebra 1, and a plane is a thing that it sits on. Okay? But we're going to start talking about it not just on the Cartesian plane like you have before, but also in reference to just overall general space. Okay? So, first thing on your example or on your vocabulary sheet. By the way, when you're doing these, don't feel like you have to get the exact wording that I do. You can summarize, you can abbreviate, as long as you are getting accurate information down. Those and help you remember this stuff later on when you're doing your assignments and studying for your tests. So a point is a location. It has neither shape nor size, and it is named by a capital letter. Now, we could have any point and name it with any capital letter. So that would be point A, point B, etc. Okay? So capital letters named are used for naming points. Like I said, probably not new information. Let me give you all a second to finish copying. By the way, if I'm going too fast, let me know, but we got a lot to do, so we got to kind of keep the speed up. Okay, a line is made up of points that has no thickness or width. Now, here's what's actually going on there. When I talk about 2 points, I'm going to talk about lines A and B. Technically, when I'm talking about a line, I'm talking about the set of all points that are in between those. And so any 2 points that I draw, there's always an infinitesimally small space between them. I could stick another point between all of those, and I could stick a point in between all of those, and a point in between all of those. And eventually they get so clustered together that I'm talking about things that are separated by such a small distance that the only way I can do it is by drawing the line itself. Realize that a line has no width, it has no thickness, it has no depth, it has only length. And even then, a line is infinitely long because it does not stop in either direction. That's why we draw the arrow on both ends. So, naming lines, that's what this bottom section is all about. There are 2 ways to name them. You can name it with 2 points on the line, provided that you also use the line symbol above it. So this says line PQ. Notice it's got the arrows on both ends. Those arrows will become important in the next class period. Order does not matter, so I also could have done QP. And let's say there's another line on there as well. I could have used PS, SQ, SP, all those different versions, right? Oh, see, and I messed up my thing. Forgot to put the line segment or the line symbol on there. Also, a line can be named with a lowercase script italicized cursive letter. So I could name this whole thing line M. Now, when you're doing that, make sure you're kind of showing it in italics or something. If your cursive is good, do it in cursive. The place where it's really important is where you're talking about letters that are also misconstrued with numbers or other symbols. So like if I was going to use an L, my script L's are always written in cursive. Okay, K's I typically put in cursive as well. That way I know it's not, the L is not a 1 or a capital I. Okay? Any questions so far? All right. A plane, flat surface made of points that extends infinitely in all directions. Now, careful with all directions. We're talking about like north, south, east, and west. There is no vertical directions on a plane, right? It just goes flat in all directions. We start adding in that vertical direction, and we start getting into what's called space, and we'll talk about space in a few minutes. There's exactly one plane through any 3 points, okay, that are not on the same line. That not on the same line is important, and here's why. I'm going to draw a basic rectangular prism here, and let's talk about points for these 3 green points. This front face that I'm highlighting in yellow, does that plane pass through all 3 green points? Yes. What about this blue plane on top? Does that plane pass through all 3 green points? Yes. So, do 3 points uniquely identify a single plane, or is it a possibility that there's more planes? There's a possibility of more. Okay, now what if instead of that point, I used this one down here? Now, does the blue plane pass through all 3 points? No. The difference is that these 3 points are not contained on the same line. So, over here on our example, we got B, D, and C. We could call this thing plane BDC. You can also use the parallelogram symbol. It's not used as often, but either one of those works. Now, again, order doesn't matter here. C, D, B, D, B, C, all that is fine. Okay? Now, if I was to throw in here a point E, and those are on the same line, I could not use BEC, but I could use DEC. Okay? There are tons of ways of naming planes. Anytime you write one on a test, I will make sure that what you write is actually valid, because it's entirely possible you come up with an answer that I didn't think of, okay, or I just didn't write down. The other thing you can do is you can write plane, and then you can use your script or italicized capital letter. So this one would be like plane K. Also, the symbol, the parallelogram symbol, would work as well. All right. Example 1. This is where we jump over to your example sheets. Well, you'll also do me a favor before y'all come back on Tuesday. Make sure that you put your names on both sides of that placard. That way I can see it from the back as well. All right, example 1. Use a figure to name a line containing point K. Anybody want to try this one? All right, what was your name?
Lucas.
Lucas, what do you got?
A.
Oh, he's taking the symbol route. Line A, yes, that works. All right, anybody else want to give a shot for another valid name?
JL.
JL?
Line JL.
Okay, thank you for correcting yourself. It is line JL. That also works. What else? By the way, there's 7 correct answers here. We got 2. If nobody volunteers, you're going to get voluntold. What's your name, sir?
Alec.
All right, Alec, what do you got?
Line KJ.
Line KJ also works. Okay. I lost it. Daniel, what do you got?
Line JK.
Line JK also works. All right. Jackson?
Line LK.
Line LK also works. And I got two more.
LJ, line LJ.
Okay, line LJ. And then one more. I hope you've seen the pattern how I'm writing this now. We got
Line KO.
line KO. Okay, all those are valid. There are two things on here you are not allowed to use, and that's the M and the B. The M because that's a point that is not on the line. I guess technically there is, in theory, a line that goes through and passes through those. However, it's not drawn on the figure, so we don't consider it. Okay. Also, the B because that's the name of the plane, so it does not work. Any questions on that? All right. Example 2, use the figure to name a plane containing point D. There is no way we could put, well, I'm not saying no way. I'm not going to spend the time to write every single one. I'll just get a few correct ones. Okay? Anybody want to volunteer? I know who my popcorn hands are. Is it Tanner?
Yes, I am.
All right.
Plane DBC.
Plane DBC, yes.
Okay, hold on.
Plane DBC works.
I have a question.
Yeah.
Can I just say plane N?
Yes, you could. Plane N works.
And is there an abbreviation for plane?
Just the parallelogram symbol. I guess you could do PL is also acceptable. Okay. Let's get one more valid one.
Plane ABD.
Plane ABD also works. A couple of things that do not work. Actually, one thing that does not work. You want to give me one? Cannot happen? Yes, sir. What was your name again? Reese. Yes. Plane ABC or any version of those 3 points does not work because these guys are in a line. All right. Any questions on that? All right. Simple enough. Whew. Example 3. Name a line that contains point A. Cade, what you got?
ABC.
Careful. How many points do we use for a line? 2. So we can't say ABC. So just pick 2. All right. A, B. Lots of different versions of that. I'm not going to go through them all. Okay. Lots of versions for it. All right. I trust that by now you can start seeing some of those patterns. Okay. Another name for line M. Samantha.
Line BD.
Line BD also works. The only other one there that would work is DB.
Or N. What?
M is what's given in the problem, so we can't use M.
Oh.
Okay. Part C, name a point not on line AC. Simone.
DB.
Yes, you're right. D and B, well, B is on the line. D is not, but we're asking for just 1 point. So yeah, D would work. You also could have done E. And please don't get snarky and creative on me and make your own points on problems like this. Okay? That happens sometimes. All right. Yes, sir.
Do we just put E or do we have to put point E?
No, just a single capital letter is fine for points. Okay. Name a point not on line L or line M. Ben, what you got?
E.
Ah, very good. Point E. Only one that works there. And quite frankly, I'm not even going to bother doing E because E is the exact same question as A. So, questions, comments, general feelings of malcontent? All right. Okay, undefined terms. This is not on your sheet, by the way. Here's what an undefined term is. An undefined term is something that is so basic or so simple that we can't really make a proper definition for it. You'll notice that for points, lines, and planes, all 3 of those, we gave examples of what they were. We gave some properties of what they were, but we could not actually truly define it the way that other things are defined. That's because they are so rudimentary, so basic, that we do not have the ability to properly define them. Now, this is not a perfect example, but words like A, okay, not the letter A, the word A. Try to come up with a definition of the word A. A, no, not like A, man. No, the word A or ah, depending on where the country you're from. Yeah.
Something singular.
Something singular. And here's the issue we start getting into. What does singular mean?
Something alone.
Something alone. What is alone?
By itself.
By itself. Okay. We eventually start circling around. If you didn't hear the stream, somebody just said, me, I'm alone. Okay. We start circling around, and eventually the word A is going to be used in one of those definitions, right? And so therefore becomes a circular definition. Okay, the word A is very easy to come up with examples of. It's very easy to come up with a contrast for it, especially when we start contrasting A versus the. Okay? We talk about a tree versus the tree, right? In that context, a tree is just one member of a set, right? It's just one of those trees over there. I don't care which one. We talk about the tree, all of a sudden we're giving a specific tree significance and we're pointing it out. Like, that is the tree that I carved me and my girlfriend's initials on, right? It's not just a tree unless you carve your initials on multiple trees, right? There's a difference in those two. But coming up with a specific definition of it is kind of difficult. Another word that's very abstract and hard to come up with a definition of is the word time. Okay? It can be done. It's just very difficult at first glance. Because so many times when you try to define the word time, you accidentally use the word time in the definition. Okay? Try it sometime. It can take you some time to do. See, I'm using the word time all over the place here. All right. Okay, undefined terms. You'll notice that for the rest of these, we are going to be building the rest of geometry from those three. Just about every single definition we use from here on out will involve points, lines, or planes, or something that we've already built out of points, lines, and planes. For example, you'll notice here that here we have points that lie on the same line. We are using those three terms to build other things. Okay? Now, the prefix co here means together or along with. So collinear is together on the same line. Then we jump down here to non-collinear, just the negative version of that, not on the same line. So to go revisit a point from earlier, we talked about you cannot name a plane with 3 points that are on the same line. The more proper way of saying that is you cannot name a plane with 3 collinear points. Okay? Just couldn't use that word yet because we hadn't defined it. Next up, coplanar. Not a complanar, a coplanar. Same idea. Points that lie on the same plane. Well, I say points or lines. Because you can have 2 points on the same plane, you can have 2 lines on the same plane. Think about the wall of our classroom over here being a plane. All the cinder blocks in the wall form lines where those cinder blocks come together. Okay, and you've got a line that goes horizontally all the way across the room. Okay, each one of those lines is all on the wall, therefore they are all coplanar. Okay, the lines can be coplanar along with points. And of course, you've also got the negative version, non-coplanar, is points or lines that are not on the same plane. Now, since a plane is a more dynamic object than a line, there are different versions of what coplanar and non-coplanar can look like. We'll get to that. Where'd that go? Yeah, we'll get to that in a minute. All right, so this one, on y'all's paper, you got sections or space to draw multiple things. I'm going to do one large drawing out here just above mine. If y'all want to do one large drawing, we're going to get all of this into a single drawing. Just do it there on the right side beside all of your example space, okay? For sketch 6 through 10. This skill is not, some people find it difficult trying to follow directions and draw the thing that we're talking about. General rule of thumb is draw the larger object first. It doesn't always work, but it's a good general rule of thumb. So sketch 6, line AB is in plane Q. Which one of those is the larger object? Plane Q. So I'm going to draw a plane, and when you're drawing a plane, just you make a parallelogram, and then that's a horrible Q. And we got line AB on plane Q. I'm going to draw a line and put A and B. All right, and I'm going to label what colors I do these in for each sketch, just so you can see it when you need to. All right, line ST intersects line AB at point P. Whew. Well, we know that line ST is going to intersect AB. We'll talk more about what intersection means in a minute, but it's going to intersect it. And then, so this is going to be ST, and then what is this point right here? P. All right. Point X is collinear with A and P. So where's X going to end up?
In the middle.
In the middle? Where? Middle of what?
Of A and B.
Does it have to be in the middle?
No.
Oh, no.
I mean, technically it could be out here on the end. I'm just going to put it right there just because that's simple. As long as it's on the line with A and P. All right. 9 point Y is not collinear with T and P. So where do we put point Y?
Not on
Anywhere you want.
other than.
Yeah, other than on the blue line.
Yeah.
And then, sketch 10. Line L contains points X and Y. Bad computer. Get off of there. And then I'm going to label that L. All right, any questions on that? You'll notice that even though my sketch is different from this sketch, it still works, right? Okay. Anytime I ask you guys to draw stuff like this, I will make sure that I take that into account because your picture will look different than my picture, that sort of stuff. All right. An intersection of two or more geometric figures is the set of points they have in common. Important thing here. Set of points that they have in common. Now, last year in Algebra 1, when you talked about systems of equations, you did the whole, elimination, substitution, and you learned how to solve by graphing. You talked a lot about intersections of lines at that point. You talked about the intersection point being the place that they cross. The reason it's an intersection is because that's the only point that makes both equations true. Otherwise, it's this point they share, the one they have in common. Okay, so different versions of this for two lines, it's just a single point, what you're used to seeing last year. However, when you introduce planes, it gets more complicated because a plane can intersect a line at a single point. Here, point S is the only point they share. Also notice that this going behind the plane or down through underneath it is a dashed line. That convention will come up a lot. You see it also here on our planes A and B with the edges of the planes being defined as behind it. Whenever two planes intersect, we kind of hinted at this earlier when we talked about the rectangular prism, those are going to intersect at a line, okay? So we got line R there. Okay, yes, sir.
So just a question on planes. So a plane is just like a parallelogram, basically, where it's 3 points on a line.
Okay, so we draw it. The question was, is a plane basically like a parallelogram? Yes and no. A parallelogram is a portion of a plane. In theory, a plane extends on infinitely in all directions. Like we talk about examples of like tabletops or walls being planes. Those are like representations of planes. They're not a perfect representation because the tabletop ends. A plane would go on forever. We draw a parallelogram because that's the easiest shape to help us identify with that concept. Okay.
So like on that, it's QS and R are collinear, basically. So would that be a plane?
So QS and R are collinear, so no, we cannot use QS and R to define a plane. because there are an infinite number of planes that pass through Q, S, and R. I mean, you can just rotate things around and always find a new plane. Okay, defined terms. I kind of talked about this earlier. Also on your sheet, terms that can only be explained using undefined terms. That's the idea. We're building everything up from there. Okay, space is the boundless three-dimensional set of all points that can contain lines and planes. The easiest way people usually think about this is outer space extends on infinitely in all directions. I mean, there's arguments among astrophysicists and stuff about whether or not the universe actually has a boundary or an end point. And so if you accept that definition, then technically outer space is not the same thing as a geometric space. But hey, it's so many billions and trillions of miles away, I'm not worried about it. It extends on infinitely in all directions. I mean, this classroom is a space because it goes up and down all three dimensions. You can put lines and planes inside of it. I believe that's the last definition, right? The last vocabulary? Okay, so we just got examples from here on out. And we're making good time. Okay, so go ahead and jump back over to your example sheet, and we'll finish these up and be done. Name the intersection of the planes O and N. Okay, I know that some of these pictures can be hard to look at with all the lines going everywhere, but where do O and N meet each other? What do they share in common?
Line A and B.
Yes, line AB. Or if you put BA, whatever. Now, does line AB intersect point D? No, definitely not. Because we've got AB over here, D is down here. But why? Why do they not intersect?
Because they're not.
Let the definition be your answer.
They're non-collinear.
What's the definition of intersection?
Crossing each other.
What did the word say on the screen?
The intersection of two.
Oh, that's not what the definition said. I highlighted in blue. Come on, refresh. It's the set of points that they have in common. And do these things have anything in common? No, they do not. All right. Sorry, I'm getting tired. I'm going to sit down. All right. So, no, because they have no points in common. Sorry, my handwriting is getting worse as the day goes on. Okay. Name the intersection of line N, or plane N, and line AE. So we got plane N and line AE. Where do they intersect?
B.
At point B. Notice the dashed line means it's going through and underneath or behind the plane. All right, name the intersection of line BC and line DC.
C.
Yeah, okay, by the way, this right here tells you they both have the same point. They're going to intersect at that point, okay? Does does line DC intersect line AE?
No.
DC intersect AE, but don't they cross right here?
Dotted line.
Oh, because it's behind, it's actually on the plane. So the answer is no, and why not?
They have.
They are on different planes and you cannot share.
Yeah. No points in common. Okay? Easy enough. Oh, by the way, let's go ahead and challenge something that you got last year. Last year you talked about intersecting lines and parallel and perpendicular lines and all that sort of stuff. What do you call two lines that don't intersect?
Parallel.
Parallel. Do these lines intersect?
No.
Are they parallel?
No.
No. See, that idea of lines that don't intersect or parallel works when you're talking about only a singular plane. However, if you introduce multiple planes or the ability to go into space, then you can have this concept called skew lines, okay? Skew are like where you have a line that goes here and then another line that completely misses it and goes here, okay? Think about, again, a rectangular prism, this line here and this line, it's a different color, this line here. They miss each other because they do this, okay? And sorry, I'm motioning with my hands and I realize people on the video can't see it, but whatever. You get the idea. All right, by the way, that is called skew. We'll talk more about skew lines in later lessons. Okay, refer to the figure. Name 3 line segments that intersect at point A. I'll give you a hint. They're all going to have the letter A in their name. A, B?
DA. Wait, no.
Yeah, DA works.
Oh, yeah. Okay. DA, AB, GA.
And then our last one here is GA. All right. Name the line of intersections of plane GAB, which is this top plane, and FEH, which is the front plane. Where do those intersect? Yes, line GH. Okay, the line that they share in common. Do planes GFE, which I believe we have, GFE is the blue plane, and HBC, which is this front right plane, do those intersect? Yeah, where do they touch? At HE. So yes, they share HE, or line HE, okay? Because that's the points they have in common. All right. Any questions overall before we stop? No? All right. So I'm going to go ahead and cut off the video. All of y'all who are tuning in online, thank you for tuning in. And we'll be back next time. And as always, stay patriotic.